Let's talk about what capabilities the SQL language provides for aggregated calculations. We can use a special function for calculations across the entire table. For example, the sum function returns the sum of all the values in a column across all rows. Average returns the average value. Min-max returns minimum and maximum value. Count returns the number of rows. There are many other functions as well. Let's consider the following example. The count function with an asterisk will return the number of rows across the entire table, which is 4. If there were no rows in the table, then this function would return 0. If any of the values in the column are null, then they're ignored in the resulting set. Specifying a column in the count function will return the number of rows where the specified column is not null. There are 3 rows in our case. Likewise, other aggregate functions do not take into account null values. If all the values in the amount column were null, then the count function would return 0, while the sum, avg, min, max functions would return null. If we're interested in aggregation by the columns, we must use the group by clause and list the columns, or an expression for grouping. For instance, we have data on 7 random movies and their ratings. Let's group them by rating and count the number of films within each rating. We have 3 movie W with a J rating, so the result table will contain a row with a G rating, the number of films 3. There are 2 PG rated movies, so the result will be PG 2. For the remaining 2 ratings, we have only 1 movie for each, so they are added as is. Summarizing, we got the number of films grouped by rating. If we specified several columns in group by clause, then the aggregating value, in our case the number of films, would be calculated for all combination of values for these columns. Where can't be used for filtering aggregated values since the condition is triggered before aggregation. Instead, you must use the having keyword and specify the conditions to apply to the aggregated values. In our case, we have calculated the number of films by ratings, and now we want to show only those where the number of films is more than 1. All other rows will be discarded from already aggregated values. Let's look at another example on aggregation. The task is count in how many films each actor played. To do this, take the actors table and the actor movies link table. Let's join by the key, the identifier of the actor. Now, in order to count the number of films, we need to take the number of rows for each actor. Therefore, we choose the name of the actor, his last name, and count the number of rows. Let's give this column an alias for the count of films. Make sure to group them by the actor's first name and last name. Let's sort our result by the count of films ascending. We see that Emily D has played in the minimum number of films, 14. Now let's see who has played in the maximum number of films. And this is Susan Davis, who has played in 54 films. For example, we want to keep only those actors who have played in more than 40 films. 40 is the aggregated value, so we cannot write this condition in the where, since it works before the aggregation. We see an error. However, this condition can be written in having. And we see that 3 actors have played in more than 40 films.